Good morning, everyone. Welcome to the first CCT partner meeting for 2023. As many of you know, our focus this year is to help stimulate coral rescue programs in as many jurisdictions as possible, to collectively give us a chance of preserving some genotypes that are representative of the region's unique endemic biodiversity that's encoded in those coral species that are susceptible to SCTLD. So this is also our first instructional webinar in pursuit of that objective. And the topic this morning is how to start your own in-situ coral nursery program. Our first speaker will be Dr. Stacey Williams, who's can perhaps start loading screen sharing now. And many of you know Stacey for her pioneering work on demonstrating that diadema herbivores can be grown in nurseries and transferred to coral reefs by their hundreds and thousands and survive in places like Puerto Rico long enough to have a really significant effect on the control of the noxious algae that tend to overgrow corals on so many of our reefs. She also gave a presentation to us last September at the Reef Futures meeting in Key Largo, when we first gathered together to start to talk seriously about techniques of coral rescue. And at that point, her focus was on enhancing the populations of herbivores like diadema, other sea urchins, and other invertebrates that feed on benthic algae. But she's also been cultivating fragments of corals for restoration, and that's the topic of which she's going to be talking. That's what she's going to be talking to us about this morning, with a focus on the in-situ components to her program. So Stacey, welcome, and please take it away.
Thank you, Judy. Good afternoon, everyone. As Judy mentioned, my name is Stacey Williams. I'm a co-founder of a small nonprofit organization here in Puerto Rico called the Institute for Socio-Ecological Research. Today, I'm going to be talking about the protocol that we use when collecting or rescuing corals from the field, and then talk about go through the different designs that we have had of our in-situ nurseries, and some of the factors that you might want to consider when developing your own in-situ nursery in your location. So with our organization and with many partners like the NOAA Restoration Center, also Department of Natural Resource and Environment here in Puerto Rico, National Fish and Wildlife Foundation, and U.S. Fish and Wildlife Service, we created this partnership to develop these land-based nurseries. And under these land-based nurseries, we created a centro. It's called the Centro de Investigación y Restauración de Organismos Marinos. It's just the Center for Research and Restoration of Marine Organisms. And we have two facilities right now in Puerto Rico. We have one in La Parguera, and this is located at the Department of Marine Science at the University of Puerto Rico in Mayagüez. And at this facility, we have a land-based coral and sea urchin nurseries. We have developed a sea urchin hatchery, and also we have in-situ coral nurseries. We just recently developed another land-based sea urchin nursery on the east side of the island in Ceiba, and we received funding from NIFWIF, so we are now starting to expand that nursery to include coral tanks. But today I'm going to be talking about the La Parguera facility, because we are discussing in-situ coral nurseries. So our coral nursery protocol, just to summarize, is that any corals that we rescue, or if we sample any tissue from an adult coral colony, we bring them back into the lab and they're quarantined for about 2 to 3 weeks. We watch and make sure that these corals are not showing any signs of disease or if they're bleaching. They're in these tanks that are isolated from our land-based nursery system. So there's no type of cross-contamination between tanks. The corals are immediately photographed and they're given an ID number. And this data, including where they are collected from, the species, the day, their ID number, is all entered into an online database. And that ID number follows them from when we frag these corals to when we outplant them to the reef. So after the 2 to 3 week quarantine, and if they're not showing any signs of disease, we then frag these corals, and we've been working with up to 10 species, three species of orbicelids. We also have Acropora palmata, Dendrogyre cylindris, Pseudodiploria strigosa, Matasteria cavernosa, also the Copophilia Meandrina meandrites, and also some of the agaricids that we are working with in our tanks. For us, I know that not everyone has tanks on land. For us, what has worked with us is that after we frag these corals, we keep these corals in our tanks for at least 2 weeks before moving them into the in-situ nursery. And we found that to help the survivorship of the frags when we do take them out to the in-situ nursery, because it gives them a chance to kind of recover. If you don't have tanks on land, you can, immediately restock your in-situ nursery with the frags. But we found that keeping them in the tanks for at least 2 weeks helped the survivorship of the small frags. So also we developed these in-situ nurseries as a complement for our land-based nursery. Our focus was really the land-based nursery, but we started with the land-based nursery with only 8 tanks, and we were running out of space. So that's when we started developing our in-situ nursery to complement our work on land. So I'm just going to go through all the problems that we had to what has been working with us now, and then describe some of the factors that you want to consider and what we feel has worked with us. So here's where we're located in Puerto Rico. This is Northern Caribbean. And where we're situated and where we do a lot of our work is in La Parguera, which is in the southwest part of the island. We started placing corals in cages, and many of you heard in Florida on that, like the case of predation. So we use these tables as fully enclosed tables. However, that created a lot of other issues, like we had to clean these tables more often. Also, the corals, there was a lot of bivalves that would attach themselves under the frags. So we had to actually clean the frags more often. If you didn't go out often enough, the sedimentation, would fall on these structures and then basically block light. So we soon moved from this design to an open design for a table. And these tables were nice, but the lower, as you can imagine, since corals need light, the lower floor didn't receive that much light. So we would see that there was a difference in growth between corals. Also, it just, again, created issues with sedimentation, and we would have to go out pretty often, depending on where you place these in-situ nurseries. you would have to go off, we would have to go out often to clean these structures and also the corals that were on the plugs. We are now working with a longer table, and it's just one floor, and this has been working well. And I will go over the benefits and disadvantages of working with tables, especially when it comes to disease. And you might want to think about using between an actual tree and a table. But these tables are really nice if you're using the larger pucks, which I'll go over for the species like Macastrea cavernosa and Pseudodiploria strigosas. We also started with a tree design, and the tree design was nice because it had these removable trays, which we still use. But this tree design had different floors, and these floors were vertical. As you can imagine, with the 3-floor design of the table, this tree design, like the bottom floors, didn't receive that much light. It also, the top floors had higher growth of algae. So we would get this really fleshy algae like Dictyota growing on the top floor. So we found that we would just have to clean these these trees more often. So we went back to the drawing board and we figured out, okay, what works, what doesn't work. And we came to this design, and I can share the dimensions with this design. If you're interested, just email me. But this is basically our vertical tree turned horizontal. So we have 6 trays that are removable, that we can place corals on. And we use this black mesh that we can, the ceramic plugs fit very nice and snug in. And I will talk about this. This tree is not for every environment. Where we have these trees is pretty calm, and there's not that much sedimentation where we have it located. So these are, for that case, this design is good for the in-situ nursery. So here's a picture to the right of the removable trays. So if the trays become really foul, we can just remove them and place the corals on a new tray. You can see that they just slide on and off, and you can secure them with cable ties or any other type of rope. Here's a picture of some of the corals. So we can use some of the bigger pucks, and I will go over the different plug size and what you might want to consider, but you can fit a lot of corals on these structures. And we've been seeing really, really nice actually growth of corals on these structures. And when we want to go and clean them, or if there's a hurricane that comes, you can then pull them down close to the bottom and actually be able to clean the corals or clean the netting or any type, or the structure if you would like. So these have been working really well for us. And we have about, I think, 4 or 5 in the water right now, and most have corals on them. So some of the factors that I think for us, we've made the mistake, and I think it's good to talk about these things, is that here are some of the factors that you want to maybe think of before installing your own in-situ nursery. And that is like characterization. So I'm getting some feedback. Sorry, I don't know if somebody's okay. So site characterization, where you want to install these in-situ nurseries. Not all sites are the same. And I will go over some of the sites that we have installed, like we have deployed some of these in-situ nurseries, and some of with our partners where they have also on the East Coast have installed in-situ nurseries. So some of the characteristics you want to think of is the wave energy. Is your site exposed? You might not want to use those tables, and I will go over some pictures show you some pictures from our partners that do work with high wave energy sites. Sedimentation, is there a lot of suspended sediment in your water? You might not want to use those trays because they just increase surface area and increase the surface for that sediment to accumulate. So that's something that you want to consider. Water flow occurrence. We've made the mistake, and I'll show you a map of where we placed the actual trees and tables in the back reef, but there was just not enough flow. And we had a lot of algae and tunicates and everything growing on these tables. So, and also you might want to think about, is there active coral disease at your site? So it might depend on what type of structure you want to install at site. So for example, so here I'm going to be talking about La Parguera. La Parguera is in the southwest. As you can see on your screen, there's a lot of coral reefs. All these red dots is where we installed In-Situ nursery at some point in time. And we are now focusing all our In-Situ nursery here in San Cristobal. And the reason for that is because at the other sites, we had problems with sedimentation, with wave exposure, and it just wouldn't work out. So I think the first step that you would want to take is that to install the structure first and wait for a couple weeks and see what grows on your structure. If there's, if you're getting a lot of algae, you might want to move that structure to another location. So that's what we do usually, is that we install a tree for a couple weeks or a table and see exactly what colonizes that table in the first couple weeks to a month. If it's pretty clean, then we decide to keep that In-Situ nursery at that location. At San Cristobal, like I said, not all sites are the same, and not all areas of a reef are the same. So the back reef is going to be very different from your fore reef. So we started with our tables and our trees close to the back reef. This is the south. So this is where you can see where the waves are coming in. So this area was sheltered. It was a little bit far away from the actual reef. But this caused a lot of problems, a lot of sedimentation, a lot of algae. Even though it was in a sandy area, we were having issues with maintaining these In-Situ nurseries clean. So then we decided to move the trees and tables to a deeper spot, more exposed, but with the deeper spot, it was still far away from the reef. And we got a lot of algae because there was not that many herbivores. We feel that the parrotfish have helped us kind of clean our nurseries. We haven't seen really predation of parrotfish like in other spots in Florida. So what we found is that the farther we were away from the actual reef substrate, the more algae we would see on our In-Situ nurseries. So then we moved our In-Situ nursery in shallower area and in like a canal between two like patch reefs. And that has been working out really well. There's a flow of water. There's, it's close to the reef substrate. So we do have those herbivores that eat the algae that could grow on these nurseries. And sedimentation, since there is that flow, we have less sedimentation on our nurseries. So this is something that you would want to consider in your location. Now, our partners at Sea Ventures, they work on the East Coast in Fajardo, and the East Coast is very different. It's a different beast. It's way more exposed. You get the northeast swells. It's high energy site. So they don't use the tables that we use, the floating tables that we use, or the other trees. What they use is this tree design where they can stick the plugs on the stems of the tree. And this works really well because it doesn't create a drag when these swells come. So they've seen a high success of corals and high growth rate of these corals when grown on these trees. So this is a different design that you can use if you are in a high energetic area. Another thing that you want to consider is what type of plug you're using. When cementing the corals too. So we use 4 different plugs, small ceramic plugs. We create also, well, really only 3 plugs, small ceramic plugs, small cement plugs, and then these cement pucks, which are those round discs. And for like sea ventures, the small ceramic plugs works because they use these plastic stems that are used to place their like expansion stems for and nailing in nails. And these stems fit really snugly in the arms. So for this case, if you want to use this tree structure, this plug is something that you would want to use. For us, like those small ceramic plugs and cement plugs are really nice because they fit really snug in the black mesh that we use for our trays. They also are small and they don't weigh that much. So if you have anything floating, you have to think of the amount of buoys that you need to keep that tree afloat. For the tables, for some of the species of corals, we use these pucks because we don't cut them small enough, like the oricelids. So the Montostrea cavernosas, the natans, the Copophilia natans, the Pseudodiploris strigosas, we all put those on these larger cement pucks. And those weigh quite a bit. So what we do usually is that we place them on tables in the field. So again, depending on what species of corals that you want to frag or produce is what you want to consider, like what structure you want to use in your in-situ nursery. Another thing you want to consider is if there's active disease in your area. In the case of La Parguera, it is like it started out at the shelf edge, it has moved inshore, and we do actually have disease in our nursery. Luckily, knock on wood, our tables, we haven't seen any of our corals that are on our tables get disease, but I would suggest placing your corals on trees if you have active disease in your site, because many have shown that having corals on the trees, you'll have a better chance of them not getting affected by, stony coral tissue loss disease if they're farther away from the reef substrate. So you might want to consider having trees instead of tables if you have active disease in your site. And also you have to think about how often do you go out and clean your nurseries, or can you clean your nurseries, and how many people do you have helping you? So like Sea Ventures, they have those trees and they go out once a month. So the picture to the right, you have to do less maintenance on that type of structure than the picture to the left is what we're using, because there's less surface area of things to accumulate and grow on. And also with the trays, we go out like every 2 weeks, every 3 weeks to clean the trays and the structure. So you have to think about like how often can you go out and clean these structures. And lastly, you might want to place these in-situ nurseries at the site where you're out outplanting the corals. That way you don't have to use more boat time to move corals from one location to the other. And also, your corals can adapt to that site. And possibly have a higher survivorship once outplanted to the reef. So those are some of the factors that we feel like for us have guided us in where we place and what we place at reefs for our in-situ nurseries. Like I said, all locations are very different depending on where you are in the Caribbean. But if you have any questions and what I have shown, you can contact me in my email. I visit our website. Like I said, this project is a partnership between many organizations and entities. And I will, I guess, take questions after Simon presents, but thank you for listening.
Thank you. ever so very much, Stacey. And while Simon has a chance to bring up his PowerPoint, let me just say that we'll take questions at the end, because I think some questions you might want to ask Stacey, you'd rather ask Simon, and the reverse, depending on how they actually describe what it is that they are doing and the challenges that they are facing and overcoming. So Simon, okay. I'm not sure we have the full. Okay, yeah, that's fine. Simon Walsh, as many of you know, is the owner and managing director of Nature Island Dive Shop in Soufriere in southwestern Dominica. And he's also the de facto reserve manager for the Soufriere Scots Head Marine Reserve in that area. And he has been incredibly active in the SETLD group chat WhatsApp that MPA Connect established last year, when people were having difficulties with treating sick corals with the antibiotic paste. And so he has already been a great help to other members of the CCT. And when SETLD came to Dominica, he mobilized on all fronts and out of nowhere created not only an antibiotic treatment plan, but also started rescuing some of their most endangered corals. So Simon, welcome, and take it away.
Okay,
and
thank
you
you
know,
very much.
oh, sorry. And before you start, folks, you can start to write questions in the chat. I forgot to say so before Stacey began talking, and don't just restrict your questions to Simon. You can also address Stacey.
Okay, thank you very much, Judy. Thank you for this opportunity to have a chat here. I'd like to start off by saying that I'm very pleased with some of the commonalities with Dr. Stacey Williams there and some of the findings that we have, because as you'll see in my presentation, it's no expertise has been used in our entire plan. We have no marine biologists, no scientists, and I must commend, I know he's on the chat here, Joey Hillman. He has been my right-hand man. Without him, I couldn't have done very much of what we've done. So I'm coming to you from the Soufriere Scots Head Marine Reserve. So we're lucky in that it is quite a small reserve. It is 7 kilometers of coastline, about 8 square miles, but that includes 7.5 square miles of water that's well over 1,000 meters deep. So as you can see here, our reef is very, very small. It only extends a couple of 100 meters from the shoreline. After that, everything is hundreds of meters deep. So it just drops off into very, very deep water. And here's a nice visual representation of what I'm talking about. Right here in the middle is Soufriere Village, where we're based, and the Marine Reserve heads to the north and south. But as you can see, the entire middle here, there's no reef, there's no offshore system. Down in the bottom here, you do see some reef out here. This is as far as it gets from the coastline, and that's very, very, very susceptible to waves and high currents. So a quick rundown of our Skittle experience, Skittle D experience. We were first found an infection in April of 2021, about 25 miles north of the Marine Reserve. We did our first treatments a couple of months later in June 2021, because we were highly encouraged to quickly get permission from government and treatment in place. And we practiced after studying online of how to treat the corals up in the north. And then in February of 2022, we had our first arrival visual identification of stony coral tissue loss disease in the SSMR. This is our resources that we have. And I think it's important for people to realize that you don't have to have a lot to put any of this into action. We really, this is where we stand now. And back then we didn't even have this. So we have three 3 marine park wardens, 1 volunteer, that's Joey, and 4 dive masters and instructors, including myself, associated with the dive shop. We are lucky that we have unlimited resource and access to all of the equipment from my dive shop. So boats, tanks, equipment, that has not been a restriction. Government support, we basically got great support in, they told us to do what we need to do because they have no resources. So they are fully supportive and they keep an eye on what we're doing and they understand what we're doing and they did their research, but they've given us permission to use amoxicillin and base to be, and also to put these coral trees up. So I highly commend them because they allowed us to act quickly, whereas we understand in other regions that hasn't been the situation. And also they've waived duties and taxes and treatments on the importation of base to be and the amoxicillin. Our finances have come from Nature Island Dive. So we put up a lot of the money. ResDM, an NGO grant that we got about 9 months ago. Joey Hillman, I got to mention him again because when he needed amoxicillin, he didn't hesitate. If I wasn't getting it fast enough, he would just go out and buy it. And then a little bit of private donations. So when we started talking about, actually, when we started observing that we were having a massive loss of, in particular, Meandrina, we realized that we needed to do something to remove these corals from the reef when we started to talk about trees. So we went online and we studied everything that we could, and MPA Connect was helpful, and many other people have given us a lot of good advice. But of course, it doesn't necessarily apply to each individual location, region, or island. So our main objective really was to isolate the colonies from what we were seeing happening on the reef, despite our treatment. Also a place to put and hold corals of opportunity. What our main objective has not been until sort of now, actually, fragmentation and outplanting. We're really thinking in Dominica about just genetic banking and trying to save and make it easier for us to monitor increasing number of colonies and species. The medium-term goals, monitoring, learning the challenges of preservation on the trees, and also to have a visible presence and project for volunteers and people that might donate. Just something that sort of show we were doing more than just treating the coral on the reef. And then long-term, of course, at some point we'll be looking at outplanting, and we need to increase. We have done some fragmentation and we've learned some lessons, but we definitely need more education in that area. So our first thing we looked at was susceptibility of corals specific to Dominica, knowing that using this knowledge, we would be able to quickly decide what we are going to put on our trees. And for us, our dominant coral was Meandrina, so MMEA and MJAC. They were by far our dominants, mainly the MMEA. So that was a high priority for us. So just looking at this chart quickly, you can see that the frequency of infection on the MMEA was highly infected and survivability was extremely low. We lost, despite treatment, almost all of our Meandrinas, except what's on the tree. And then you look down and you have better survivability rates until we get to both SSID and the pillar corals, where we can't necessarily say and give any hard numbers, but we've definitely lost most of our pillar coral at this point. And our SSID, we're not sure what is the problem with SSID. We can't really identify that it's always Skittle D. So once again, just like Stacey talked about, location was our first thought. Where are we going to put our trees? And our plan A was in the middle of the MPA, because we had, very similar to what Stacey was showing, nice gradually descending sandy areas. But the disadvantage to that was we would need a boat to access it. There's no road, there's no beach access. So plan B, we said, let's put it in the easiest place possible, which is right in front of the dive shop. Easy access, we can walk out from the dive shop, walk across the road, enter the water, and see the trees. The negative thing there was water quality, high sedimentation, and runoff. And plan C was further down the marine reserve, along the road, but further away from the village. Easy access, cleaner water, very little infected reef, because the reef here is not very healthy anyway. So very little Skittle D, and cleaner water. And so we have ended up putting our trees, three trees here and 2 trees over on the Plan C area. So our first tree was a meandrina tree, a maize tree, 6 branches, and we only put maize on this tree because we were convinced, and still are, that because of our high density of maize corals on our reef, and these being the most susceptible, that this was becoming a vector for the disease and infecting a lot of our other reef systems. So we did not want to mix any species on this tree. So it's literally just our maize tree, 6 branches, 4 colonies per branch, open system, meaning the pipes are open. There's no flotation within the PVC. It's moored in 24 meters deep, and it's 80 feet, and it's 8 meters deep from the surface. So this was our idea of removing the colonies from the reef system as high up as we could go and still have it practically close to shore because it does drop off very quickly. The other really interesting thing about this is, and we've had to do it once, is in the event of a storm system, it's easy to pull this tree quickly down to 24 meters where it's going to be out of the surge zone and then let it up the next day and bring it back up. And we've done this in some pretty big storms, and so far it's been highly successful. So our justification for this tree and our thinking of it was, the rapid loss of meandrina on the reef, the ineffective treatment. Most of our treatments were not breached, but the reinfection rate on a different part of the colony was our problem. And we were watching all the small juveniles dying off on the reef as well. Lifting the colonies up into midwater, easier monitoring, and genetic preservation long-term. So our decision was, what are we going to use to do this? And of course, we want to look at easily available materials. So PVC pipes. We used ceramic tiles, as you'll see in the next one. We just went to the store and asked for the ugliest tiles. And believe me, the color of some of these tiles, the best place they could be is on a coral tree. And then PVC board cut to match, pre-drilling holes, and reusing zip ties to reduce plastic, single-use plastic. And then the only thing we had to import was the all-fix epoxy for the coral. And here we have a sort of kit where you can see one of the branches on our 5th tree. You can see the ceramic tiles. And interestingly, we don't have access to the plugs that Stacey used. And I think we stumbled into something here. By using these large 4-inch tiles, we have bought ourselves considerable amount of time because we're not ready for fragmentation and outplanting. So the tiles, as long as we can keep them alive, they can grow a lot bigger before we decide to fragment and outplant. So we unknowingly, in our genius plan, bought ourselves a couple of years before we need to think about outplanting. And here's a close-up, pre-drilled holes. And these PVC sections we cut from PVC board, and we just used pipe glue and clamps to hold them on here because we didn't want to drill holes into the pipes because we were thinking we might use the pipes for extra flotation. And here's the finished product on a single tagged meandrina on the meandrina tree. So it was easy to work on. We actually love this tree. It's a very nice tree, and it's our first and also one of my favorites. Our second tree was a tray system like this. And as Stacey said, what we don't like about this was too much flat area for algae and sedimentation, way more cleaning and way harder to clean. But our thought process was we could put a lot of colonies on this. But now the weight of those colonies, because we are using bigger colonies, has made it difficult. And this is nobody's favorite tree. Although we're still using it and we have a lot of colonies out on that tree now. So hard to clean. We will not repeat this design. So here's our broken road tree. This is our 3rd design. Here you can see we came with a branch system, but instead of only 8 now, you've got 12 on each branch. You can see us laying it out here and hanging it to sort of test it and sort of pretend that we're cleaning it. And here it is in the water. This is a 48 mixed species, closed pipe so that there's flotation within the pipes. It's in 18 meters of deep and about 10 meters from the surface. And here it is with the mixed colonies. So we have all sorts of different colonies on here. It can be a little tricky when cleaning not to get tangled up in the branches above or below you. But with a little care and good buoyancy, it's easy to do. As you see, all of our trees are in mid-water, so it makes good buoyancy on the volunteers especially important. And here we have a polyp of MCAB on the tree. Our fourth tree is very simple, the tray tree, and we built this pretty quickly. We just wanted a quick tree with only pillar corals on it. So we have pillar corals on here. You can see one of our happy pillars here. We have about, I think we have actually five of them on this tree right now. Our last tree, the fifth one, we just did this one recently, and I got to give credit to, again, Joey, my volunteer in right hand. He's been in consultation with me, but we've been designing this. And here we went to a spiral. So we call this a spiral tree. It's a closed system, so there's flotation within the pipes, plus pretty heavy buoy on it to keep it up. And it's in about 21 meters deep, and again, about 8 to 10 meters from the surface. And here we have recently, as we have started to see the collapse of our large pillar corals, we've started to take pillar corals and put them on this tree now. But this will be a mixed species tree. And this is what we call the green room. So we have here, you can see a Disto and a Mang, an OFAV, Meandrina, and OFS, and a CNAT. So these are waiting to be put out onto one of the trees. So our conclusions, you need a clear objective. We can't say we necessarily had one in the beginning, but we made objectives as we went along and we understood better what we were doing. As Stacey said, location is key. And I think one of the main thing is, how often can you get out there? Do you have a boat that's always accessible? If not, do what we did, which was go from shore, which I know is not going to be a viable option for many. What are your human resources? We feel that we are maxed out with 5 trees and the 6 or 7 people that we have total. We need to clean these trees, some of them twice a week, some of them once a week, and your water quality is important. Our next steps, In-Situ, ex-situ system. I'd love to have what Stacey talked about there with being able to put them in quarantine before we put them out on the tree. Also, it would allow us to do more fragmentation and observation of them after frags. And our next thing we want to do is some coral spawning calendars and propagation. Thank you very much.
Thank you, Simon, for giving us so much more to think about. And I'd like to open up now to questions, and perhaps I would start by asking Stephanie Schottmeyer to ask Stacey the question that she put in the chat about the logistics of using a land-based quarantine system prior to installing.
Thanks, Judy. Yeah, I was just thinking that perhaps if, you know, a land-based kind of quarantine would be used, it would be beneficial if you could share, you know, specific parameters with everyone about, you know, and this could also be in an email out to everybody if some of these parameters are too much to list right now, but things such as, you know, what is your light, PAR in particular, what kind of water flow are you using? What's the water source? Do you have any type of cleaning or feeding regime, or is 2 weeks just short enough that you don't necessarily really have to worry about that?
Yeah, hi, Stephanie. Yeah, thank you for your question. I can send out more details in an email if this would be helpful. But for light PAR, we try to strive at between around 200 PAR in our tanks. Our PAR in one of our tanks at noon is at 238. The water flow, we do have wave makers in our tanks. And we do feed our corals, and I can share the info of what we feed them. We also have snails and sea urchins in the tanks to maintain the algae low. And if you are planning to have corals in the tanks, you're going to have to clean them, even if it's like 2 weeks. So you're going to need somebody to help you clean those tanks. And depending on what are in the tanks, like we have sea urchins, And sometimes they produce a lot of feces. So you're going to have to, like, we clean the tanks pretty much every day. The snails don't produce so much feces. So you might want to have just snails in your tanks. But I can send out all this information to you in an email, or to anyone who is interested, of the parameters that we have in our tanks.
Yeah, that would be great. I think, if you could maybe provide that to Judy and Dana so that they could share it to those that are, okay, that would be great. Thank you.
Yes, we could share it more widely, and also post them online when the recording goes online as an adjunct to the recording. And thank you for that answer. I also had some questions about the quarantining, and which you have mostly answered, but I was wondering, what do you do if, because you are in an area that is infected, what happens if one or more of the corals shows signs of being ill? Do you throw everything out and start over, or what's the response?
Well, first we amputate the disease part. So we amputate the area that shows disease and a little bit of what we consider healthy tissue. So we first amputate, and then we monitor that coral for another 2 weeks. We've been using, actually, because if anyone on this chat has land-based nurseries, the orbicelids are very vulnerable to ciliates. And we've been using a diluted peroxide solution, and that's actually been also helping us with disease. I can provide the dilution that we're using of peroxide, but we try also treating them with peroxide, because other products like Lugol solution, we haven't had that much success with. Also, there's, I forget, there's an aquarium product called Reef. I forget what it's called. But yeah, we like, it didn't help us with ciliates or disease, but we found an actual, like, percentage of peroxide, that hydrogen peroxide, that does not kill the corals, but kills ciliates and also helps us with disease. So we amputate first, we treat them with hydrogen peroxide, we monitor, and if it continues to show signs, then we discard. Because we collect small pieces, we don't collect really large pieces of corals when we don't collect full colonies of corals just as yet.
So if you do get one of these corals get infected, the disinfection of that one coral is done in a separate container from the other? Okay.
Yeah, so that coral is then removed. Sorry, I should have mentioned this. That coral is removed and placed in a separate tank that is just for diseased corals, or corals that show signs of disease. So we remove that coral and we place it into another quarantine tank, and then we go through the procedures of amputating, watching, and treating with hydrogen peroxide, watching. And if it's then okay, we remove that and we place it back in the tank, and then we watch it for another couple of weeks before we then decide to microfrag it or move it to the other system, because we have two different systems. We have a fully open system and a semi-closed system. So the fully open system acts like its own quarantine, because those tanks are isolated from each other.
Okay, well, thank you very much. And I do have one more question, but others, please raise your hands or write something in the chat to ask our two presenters. How many snails do you need to accomplish the same amount of algal control as one diadema? I mean, I do appreciate that snails defecate a lot less per individual than a large diadema does on a nightly basis.
Well,
How good are the
with,
snails if you don't have any diadema in those tanks?
well, the diadema, we only use really small diadema, less than like half a millimeter, because once the diadema get bigger, their spines, we have never seen diadema on the coral, but they like to get to eat the algae that grows right that on the plug close to the coral tissue. So they end up actually damaging the corals. So once the diadema get big enough, we remove them and we only keep small diadema in our tanks. So unlike diadema, the snails, I have to count how many snails we have in our tanks, but there's quite a bit, like hundreds. The snails actually are really nice because they're able to get in that crevice of that plug and that coral piece, and they do not damage the actual coral tissue. Another sea urchin that's really nice is we're growing out is trypnustes. Small trypnustes are, because they don't have long spines, they're able to effectively graze around the plug and not damage the coral tissue. But I wouldn't put large diadema in your tanks because they're going to damage your coral frags. So I would suggest using snails first if you don't have a way to use tiny or small urchins.
Well, one begins to get an appreciation of how complicated this all is. And I see that Stephanie has written in the chat that the Florida Coral Rescue Project has created instructions for how to do all of this. And I was going to say that having a presentation just on that topic is something that I was hoping to organize in the future, but we're already halfway there. So that's really great. Questions for Simon? Does anyone want to raise their hand or write something in the chat? While waiting, I can ask him. I believe he's planning to introduce some herbivores this summer to his, I'm not sure if it's to his trays or to his trees or both. And maybe he can tell us about that. Sorry,
was addressed to me, right?
Yes.
Yeah, no, we don't have any plans for that. We don't have any In-Situ system, so we don't have any trays. We only have the trees. We do find quite a few juvenile urchins on the trees sometimes, which we're happy to see. As you know, we had the diadema die-off here, so every time we see them, we're very happy. But we haven't. We basically keep our trees clean by scrubbing them clean.
And something else I wanted to say about Simon is that I was really impressed that he has some survivorship information on how well his trays and trees have worked for the different species. And that kind of species level survivorship information, I think, is going to be very valuable going forward. And we don't often see that in the accounts of the restoration trials that have been undertaken to date in the literature, which of course is mostly with different kinds of corals for other purposes, but is certainly to be encouraged, and I applaud you for that.
It's one of the things we had a little difficulty with was, sometimes with cavernosa, for instance, it was quite a trick to get to learn at what point during an infection you could actually treat a cavernosa because they're so slippery and slidey and a treatment wouldn't stick. But then once we got the technique down, which was sort of waiting until there was quite extreme polyp die-off, so you had a good skeletal to attach the treatment to, although it was quite difficult to treat, the effectiveness on cavernosa was very, very high. And most of the time, if we could keep monitoring it and keep treating it, or at least keep monitoring it, a lot of times we didn't have to retreat it. we saw a very high survivability in MCAV in ones that we treated, as opposed to pillar coral, where we were given the illusion of success in the beginning. We definitely had a lot of success, but then we seemed to sort of see a almost systemic wide collapse of the system.
Well, if we don't currently have any more questions, I'm going to turn the meeting host over to Dana Wisenich Mendez, our main team lead, who will introduce Beth Virchow and also call for other random observations as people may care to make. Dana.
Thanks, Judy. Can you hear me?
Yes.
Okay, great. And thanks to Simon and Stacey and Judy for organizing that session. That was really interesting. And I hope everyone finds this kind of very practical, hands-on experience that they shared with you today helpful in thinking about how approaches that you might be able to take. So as Judy said, hopefully we'll be able to continue providing these practical webinars for all of you who are interested in getting started in this type of work as a part of your recovery from stony coral tissue loss disease. So, but yeah, we just wanted to we have a couple, or at least one announcement that we wanted to make some time for. We have a great opportunity coming from AZA, and Beth Virchow joined us here to share information on a new training program that AZA is setting up. So Beth, I don't know if you wanted me to show the slides that you shared, or
I think I'm just gonna keep it a little short, Dana, and I appreciate you checking in on me. I've had some stinking connectivity issues today, and I saw I'm like, I'm trying to get on, so thank you for holding a spot for me. I'll just share what we've got going on, and then also I've got the link here in the chat to the whole application package. What I'm talking about is the Coral Aquarius program. We realized very early on in the Florida Coral Rescue that the resource that would be probably most limiting to our efforts would be people, not necessarily space and not necessarily funding, but people, the skilled expertise, the good coral aquarists that can either manage nurseries or just has knowledge of the husbandry of these corals. And so very early on in the project, we started thinking, well, how can we build our base? How can we build the resource that we know is going to be limiting as we move forward and we get more and more and more facilities? And then as the disease started to sweep through the Caribbean, we felt that in conversations with our colleagues, many of you out there, you also had those same challenges and those same worries. So we've come up with the Coral Aquarius program. It is a 2-phase course. It is, the first phase is a digital phase that is hosted by the aquarium vet. And that is a very respected aquatic animal medicine online learning platform out of Australia. Dr. Rob Jones hosts that. There are 4 components of that online course. There is coral biology, life support, water quality, and animal welfare, which is really important when you're talking about managing wild animals for a long time in human care. And then the second phase is an on-site phase, and it's totally manual-based, experiential, and that is being hosted, that phase is being hosted by one of 4 Florida Reef Track Rescue Project facilities, the Florida Aquarium, the Florida Coral Rescue Center. The Florida Aquarium is located in Tampa. The Florida Coral Rescue Center is located in Orlando. Omaha's Henry Durley Zoo, which is located in Nebraska, Omaha, Nebraska. and then the Georgia Aquarium, which is of course in Atlanta, Georgia. The experiential second phase of the course is a week-long, travel days on either side. So you'll be traveling on Sunday and begin bright and early on Monday and finish up your course, your on-site course on Friday afternoon, and then you can travel back either Friday evening, depending on what your flights are. The link that I put on the chat is to the application package, which goes into a lot more detail about the course. And of course, it gives you a link to me. So if you have any additional questions that you might want to have answered, I'm available to that. We are looking into scholarship programs, and those scholarships may be available to support applicants who may need financial assistance. So that's always a good thing. And we're hoping to have that when the course kicks off. So the application package include the link to the application, and applications are due at the end of March, and all of that information is in the package. So download that package, share it with folks. We are really looking for this to be a resource that is not national, but international in its scope and scale. And we hope that you folks will take advantage of it and use it as an opportunity to build your benches, as we hope facilities here in the US will do as well. So thanks, Dana. Thank you, Judith, for allowing me to have that time.
Thank you, Beth. Any questions for Beth? And just so everyone sees, she did put the link to the application package in the chat, the Zoom chat. So please, if you're interested, click on that to get more information. Any questions for Beth?
I'll ask a question. This is Judy. Would it be possible for more people to take the initial virtual course, even if it turns out, like, say, they can't get a visa to go to the US because of their country of origin in the Caribbean at the moment, for the in-person training part? How open would the first part be?
Judy, the courses in the online portion of it are available through the Aquarium Vet already. We are looking at those 4 modules as a foundational experience, educational experience, rather than truly the meat of the experience.
Sure.
But those courses are already available, and I believe each module is 298 Australian dollars to take each module. With our program, within our program, we are getting all 4 modules for the students at 250 US dollars. So it's a substantial difference in the course, that phase of the course. But those courses are available already.
Well, that's good to know.
Yep. Yeah, you can take those, and they are vet school level, very robust curricula within those modules. So they are good courses. And the welfare one is already offered for free anyway through the Aquarium Vet, because we all want our animals to be welfare and well-being taken care of.
Yes.
Beth, where can we get information on how people would register and participate in those online courses?
You can Google the Aquarium Vet. And,
the Aquarium Vet, okay.
Yep, and it will pop right up.
Okay, great, thank you.
But what we're hoping is that people will take advantage of the whole course, because you will be studying and working under some of the most impressive coral minds that we've got in the US, at least, and be able to share with you the experience of not only caring for these corals just for a short term, but the long-term investment. You learn a lot about coral system design, coral health management, as well as coral identification and that sort of thing. So we hope that folks will take advantage of the whole package.
Thank you so much. Okay, are there any other updates or announcements that folks would like to share? any opportunities or just updates on the good things that you're doing in your efforts to respond to or recover from SCTLD. Okay.
Well,
Oh,
I will,
somebody has got your hand up, sorry.
yeah, I will jump in if nobody else is. First off, there's been a very interesting conversation going on in the chat about disinfecting pillar corals and the fact that small fragments don't do as well as larger pieces. And I don't know if maybe someone wants to comment on that, but Stacey perhaps. But first, what I will say is this is in the more random corner part of the discussion, is that as a few of you know, Karen Neely has been saying for several months that she has been seeing thick colonies of Orbicella fabulata, the star coral, and Pseudodiploria clivosa, the flattened, awkward-looking brain coral, that look as though they have stony coral tissue loss disease. They die very rapidly. They have multiple lesions. They start at different places on the colonies, and so they treated them with amoxicillin, and the treatment didn't take. It wasn't useful at all. And moreover, as the summer and fall progressed to winter and the water cooled, the diseases on these colonies waned. So it looks like stony coral tissue loss disease on these two species, but it doesn't really behave like it over the long term, and it's resistant to antibiotic treatment. So she was asked to describe these by a couple of people, and she's written it up as a short white paper type of quick look report. And I have a copy, and she has said that we can distribute it to anybody else who wants to see. This is a further complication to our, sometimes confusion as to whether or not we're looking at stony coral tissue loss disease, or perhaps wondering why treatment doesn't work for some individual corals. And I hope to be able to have it posted shortly at the AGRRA website. But in the meantime, if anybody is desperate to see it, let me know and I will send you a copy. The disease field appears to be evolving around us even before we know what stony coral tissue loss disease is caused by, for sure. Now, perhaps really quickly, Stacey, do you want to say something about, or Simon, about how to manage de-silled pillar coral, because it's so iconic and so desired and so troublesome for both treating and rescuing?
Yeah, for the dendros, they're tricky, especially in tanks. Like at first we weren't feeding them, and like someone has mentioned, like cutting them small, they don't do very well when you cut them small. They, like other species, like the we can't cut the strigosas also very small. And with dendros, they like a lot of flow in the tank, and we have to feed them. So yeah, they're really tricky in growing them in situ nurseries and also in the tanks. So right now we feed them I believe 3 times a week, on Monday, Wednesdays, and Fridays, or at least, I believe 3 times a week. And we give them a different, like, spirulina, refroid mixture, mysid shrimp, crushed up mysid shrimp mixture. And so far they've been doing okay. But yeah, they're much more sensitive than the other coral species.
Yeah, I would say in situ, that's also the case. Our first tree was the one that's right in front of the dive shop. So the more sedimentation, more algae. So they don't seem to like that, but they do seem to like when we sit and watch the tree is moving back and forth in the water column. And so we're sort of hoping that stimulates or copies the effect of current. And our big dendros seem to be doing just fine. But almost all of our fragged dendros died. So we didn't have a lot. We had about 8, and I think 7 of them did not survive. And we didn't cut them that small, but they still didn't make it. So now that we have a tree that's over in the lower part of the marine reserve where the water quality is excellent, we're wondering maybe they'll do a little bit better over there. So we'll know in a few months.
Okay.
Yeah, I think we're about done unless there are any last updates or announcements to share. Okay, thanks everyone. Hopefully we'll be back in May. Just hold your calendars. We shoot for the second Monday of the month. I think we're gonna move to 1 p.m. Eastern Daylight Time.
Dana, real quickly, Ingrid had a question. She had her
Oh,
hand raised. If you could,
sure, yeah.
Ingrid, if you want to ask your question.
Oh, I just wanted to say, can everyone hear me?
Yes.
Yes.
Sorry, I had to jump in. I just put my son down for a nap, so I missed a chunk of it, but it was really great to hear everyone talking. I feel like a little bit like we're in an AA meeting. So like, I feel like we're Barbados and we have SCLTD. I thought I'd just say hi and introduce myself to the community that are dealing with it. I actually spent the last 10 years in Hawaii doing coral restoration work with Zach Forsman and other folks. So I just wanted to say a quick hi and introduce ourselves to the community. I'm sure we'll be seeing lots more of you guys in the future. So I guess we'll be more interested in, because we only got the infection potentially around October, November time. So we're dealing sort of at the beginning, I guess, of the outbreak. But we will probably be looking to do the recovery aspect further down the line. So this has been really, really useful. Thank you.
Thanks, Ingrid. Yeah, we were sorry to hear about your observations. And just so you know, there is a representative of the Barbados government that's been participating in this group. So we're gonna follow up both from the email that you recently sent, as well as with them to follow up and see what kind of information and support we can provide you guys as you figure out what your plan of action will be.
Yeah. Okay. Thank you very much.
Thank you.
And Ingrid, I would just reinforce what I think Simon said, which is that you can't wait too long before you get started on this process.
I think that's our goal, is hopefully to start as soon as we possibly can, but obviously it's down to funds and political will and all the other aspects.
The encouraging thing about these in-situ nurseries, like the ones that he has put up in Soufriere, is that you can construct them with materials that you can buy in a hardware store.
Yeah.
So it's not that expensive. And if you have a volunteer group, as I know Coral does, you should be able to get started even, as soon as you get government permission, even before you can, get a dedicated plan of fundraising.
I think the group is particularly interested in the epoxy amoxicillin treatment to the current colonies.
Everybody is at the beginning.
Yeah, that's what my personal experiences with reef restoration and mostly with the slow boulder coral. So it's interesting to see the Caribbean move from the Acropora to the sort of mounding corals, where my expertise actually lies. So I feel like I can actually be useful here, which is kind of, that's good.
We
Can I
have
just
another
add,
question from, oh, go ahead, Simon, go ahead.
can I just add a
And we have
quick
one
one?
other question.
I think Dominica was in a unique position at the time when we got stony coral tissue loss disease, and that we were pre-warned, pre-armed, ready, had permission, and everything was in place for us to take on the treatment right away. So we had a fridge full of base-to-B and amoxicillin before the disease came. Barbados you have the opportunity to also, you know, you're a little bit behind already for sure, because you're talking about 4 or 5 months that you've had the disease. You need to act fast, and we can tell you without a doubt, and we do have the data to show it, that early treatment and aggressive treatment really makes a difference. You'll still have massive loss, but it makes a huge difference when you compare it to people that have not used the treatment. So yeah, get moving.
Yeah, well, I will add that in many sites, it looks as if the disease is still in the invasion stage. So they're not desperately late in getting started now.
It's already traveled about 20 kilometers upshore from the original initial sort of impact site. But that's because there's sort of, you know, ports and boats and stuff. But then apparently there's a site in between the two sites where we found infection where it hasn't occurred. So yeah, I think the boats are moving it around the island at the moment. So I think, yeah, I think we're in the earlier stages in a lot of sites, but the main introduction site looks pretty bad.
I think we still had one question from Nilda Jimenez. No, did you still have a question, Nilda?
No, I just wanted to make a comment, but I believe Simon did. I was just highlighting the need of acting fast and having a plan of going out there very frequently. The treatment does work, but it depends on going out frequently with certain periodicity. If not, it will fail. And it's very urgent. It's really urgent.
Thank you for those sobering words.
I need the money and the resources.
Well, if nobody else has any comments, Dana, would you like to close the meeting?
Yeah, sure. You can, Judy. Go ahead. I think we're all done unless there's any last comments. Calling once, calling twice. And our core team will reconvene in April. Look for our meeting announcement and save the date. And otherwise, hopefully we'll be providing another webinar with some other good examples. If you're aware of any that you want us to highlight, please reach out to Judy and I and let us know. And we'll be in touch. Thanks, everybody. And thank you. Yes. Thanks again to Stacey and Simon for the deep dives into all of your hard work.
Thank you.
Thank you.
Thanks,
Thank
everybody.
you.
Bye.
Bye.